Welcome everyone to the Whispering Lab. If you love the content, please like and subscribe to the channel. Find a place where you can rest, a place where you can feel safe and at peace. Allow your body to grow heavy, to sink softly into the surface beneath you. Let go of the day, its worries, its noise, its hurried pace. That can all wait until tomorrow. Tonight, we are going on a journey. Not a journey of miles, but a journey of the mind. We are going to drift calmly, peacefully into the vast, quiet expanse of the cosmos. We are going to gently turn over one of the most profound and peaceful questions ever asked. A question that whispers to us from the silent, stardusted darkness. The question is simple. Where is everybody? For as long as we have been human, for as long as we have looked up at the moon and the canopy of stars scattered across the night sky, we have wondered, is this it? Are we all there is in this immense and silent universe? Or are there other minds, other beings, looking up at their own sky, from their own world, wondering the very same thing? Tonight we are not here to solve this puzzle. We are not searching for an answer in a frantic or urgent way. Instead, we will simply explore the mystery. We will drift through the ideas, the paradoxes, and the possibilities, like a gentle river flowing through a quiet landscape. This is a journey for the curious and peaceful mind, a bedtime story for the cosmic soul. So close your eyes if you haven't already. Take a slow, deep breath in, filling your lungs with calm, and as you breathe out, let go of any tension you might be holding. Breathe in and out. Let the quiet of deep space fill your room as we begin our gentle search for our neighbours in the cosmos. Before we can truly feel the weight of this question, we must first feel the size of the room in which it is asked. The universe is a place of almost incomprehensible scale. Our minds are not built to grasp such distances, such numbers, but we can try gently. We measure space in light years. A light year is not a measure of time, but a measure of distance. It is the distance that a beam of light. Now imagine that beam of light, travelling for an entire year. The distance it covers is 1 light year. It is a vast, vast distance. The closest star to our own sun, Proxima Centauri, is over 4 light years away. A message sent at the speed of light would take more than 4 years to get there, and another 4 years for a reply to come back. Our home, the Milky Way galaxy, is a sprawling spiral city of stars. It is about 100,000 light years across. To travel from one end to the other, at the speed of light, would take 100,000 years. Our galaxy contains, by some estimates, up to 400 billion stars, 400 billion suns, many with families of planets of their own. And our galaxy, This immense city of stars is just one. As we look out into the deep darkness with our telescopes, we see other galaxies, billions of them. Some are spirals like our own, some are fuzzy ovals, some are small and irregular. Each one is an island containing billions of stars and trillions of planets, separated from its neighbours by millions of light years of empty, silent space. So when we ask, where is everybody? We are asking this question in a house with billions of rooms, each room containing billions of potential homes. The sheer number of chances for life to begin is staggering. It is this number that makes the silence so loud. It was this very sense of scale that led to the famous question. The story begins not in an observatory, but at a lunch table on a bright summer day in the year 1950. A brilliant scientist named Enrico Fermi was talking with his friends. Their conversation drifted, as conversations often do, until it landed on the possibility of alien life. They spoke about the age of the universe, nearly 14 billion years old, and they spoke of its size, the hundreds of billions of stars in our galaxy alone. Many of these stars are so much older than our own sun, billions of years older. If life is a natural process, like a crystal forming in a solution, then it should have started many times, in many places, and some of those other worlds would have had a huge head start on us, a head start of millions or even billions of years. Now, imagine a civilization with a 1,000,000-year head start, or a billion. Their technology, their understanding, would seem like pure magic to us. The ability to travel between the stars, or at the very least, to send out powerful signals and messengers, should be simple for them. Our galaxy should be filled with their radio chatter, their lights, their monuments. It should be a bustling, noisy place, with evidence of advanced cultures plain to see. Enrico Fermi listened to all of this, and then he asked a very simple question. A question so simple and so powerful that it has echoed through science ever since. He asked, where is everybody? If the galaxy should be full of civilizations, why do we see nothing? Why do we hear nothing? When we turn our radio telescopes to the sky, all we hear is the natural, random static of the cosmos. The universe is quiet. It is profoundly silent. This is the heart of what we call the Fermi Paradox. The math suggests the universe should be teeming with detectable life, but the evidence we have, the reality we see, is an empty stage, a great, silent theatre. Is the silence a sign that we are truly, completely alone? A single lonely point of light in an endless darkness? Or is there another explanation? Something deeper, something more subtle, something we have not yet understood? That is a question we can hold gently as we continue to drift. To try and get a better handle on this great question, an astronomer named Frank Drake came up with a famous idea in 1961. It is called the Drake equation. It sounds complicated, but it truly is not. It's not meant to give us a final, concrete answer. Instead, it is a way to take the enormous question of how many aliens are out there and break it down into smaller, more gentle pieces. It is a way to organize our thoughts and to appreciate what we know and what we do not. Think of it as a recipe. Each ingredient is a number, a question, that helps us think about the final result. Let's walk through the recipe together, one ingredient at a time. Slowly. The first ingredient is the rate of star formation. How many new stars are born in our galaxy each year? Think of it as the gentle pulse of the Milky Way. We have a reasonably good idea of this number. A handful of new suns igniting in clouds of gas and dust every single year. The second ingredient asks, what fraction of those new stars have planets circling them? For a long time we had no idea. We only knew our own sun's family, but thanks to our amazing telescopes, we now know that planets are incredibly common. It seems that almost all stars have planetary families of their own. The sky is full of worlds. This number we now know is very high. The third ingredient is, of those planets, how many just are in right place for life as we know it? This is what scientists call the habitable zone, but it is sometimes called the Goldilocks zone. Not too hot, not too cold, but just right. It is the perfect distance from a star where liquid water could exist on a planet's surface, a gentle ocean, or a peaceful lake. We are finding more and more of these worlds every year. From here, the ingredients in our recipe become more mysterious. We leave the shores of what we know and wade into the waters of what we guess. The next ingredient asks, on what fraction of those just right planets does life actually begin? Does life always start where the conditions are good? Or is the spark of life itself, the jump from simple chemistry to simple biology, an incredibly rare and precious thing? We only have one example, our own Earth, so this number is a profound mystery. And then, on the planets where life does begin, what fraction of them eventually give rise to intelligent life? Life that can wonder, that can build, that can look up at the stars. Life on Earth existed for billions of years as simple microbes. Complex life is a more recent development. Intelligence, even more so. This number is also a deep unknown. After that, what fraction of those intelligent species develop technology that we might be able to detect, like radio waves, or massive structures visible across the light years? Is technology an inevitable outcome of intelligence? Or is it a strange path that few cultures take? And finally, the last ingredient, the most uncertain and perhaps the most sobering of all. For how long do those civilizations last once they begin broadcasting their presence to the cosmos? Do they continue for millions of years, becoming timeless members of a galactic club? Or do they flicker out after only a few centuries, a brief candle in the cosmic wind, succumbing to war or exhausting their world's resources?
With this great question in our hearts, how do we actually search? How do we listen for a whisper in the vastness of space? For most of the time we have been looking, our main tool has been the radio telescope. These are like gigantic ears pointed towards the heavens. Some are single, massive dishes nestled in quiet valleys. Others are vast arrays of smaller dishes, linked together to act as one enormous ear. The idea is a simple one. Any civilization with technology like ours probably uses radio waves to communicate. For their own television, their own radio, their own version of a cell phone. Some of these signals might leak out into space by accident. Stray whispers traveling forever outwards. Or a civilization might choose to send a message on purpose. A powerful, deliberate broadcast, a beacon, an interstellar hello, a simple "we are here." For decades, patient scientists in a project called SETI, which stands for the Search for Extraterrestrial Intelligence, have been using these giant radio dishes. They point them at one star, and they listen. Then they point to another star, and they listen again. Hour after hour, year after year, they are listening for a signal that sounds artificial. The universe is naturally noisy. Stars, pulsars, and galaxies all produce radio waves, but this natural noise is like the sound of a waterfall, a broad, messy hiss across all frequencies. An artificial signal would be different. It would be like a single, clear flute note played against the roar of the waterfall. A narrow, focused signal, something that stands out, something that says, "I was made." So far, they have found only silence, only the waterfall. But they continue to listen, patiently, hopefully. In more recent years, our search has expanded. We have begun to look for other kinds of signals. Some scientists think an advanced civilization might use powerful beams of laser light to communicate across the vast distances between stars. It would be far more efficient than radio. So now we also have telescopes that watch for a sudden, brief, unnatural pulse of light from a distant star system, a cosmic lighthouse blinking a message across the dark ocean of space. We have not only been listening, we have also tried, in a few small ways, to speak. We have sent our own messages into the void, not in the hope of a quick reply, but as a gesture, a statement of our own existence. In 1974, a message was sent from the Arecibo radio telescope in Puerto Rico. It was a simple picture, a drawing made of binary code, ones and zeros. It was designed to show a few things about us. It showed our number system from 1 to 10. It showed the key chemical elements that make up our bodies. It showed the double helix structure of our DNA. And it showed a simple figure of a human alongside our height and the population of Earth. This message was aimed at a globular cluster of stars called M13, about 25,000 light years away. The journey will take 25,000 years. If anyone is there to receive it, and they send a reply immediately, it will take another 25,000 years to get back to us. It was not a conversation. It was a greeting card, thrown into the cosmic wind, and, perhaps most famously, two spacecraft named Voyager 1 and Voyager 2 are now drifting in the space between the stars. They have left our solar system behind, and each one carries a special gift, a golden record. These are phonograph records made of gold-plated copper, designed to last for 1 billion years in the cold of space. On their covers are simple diagrams showing how to play the record and showing the location of our sun relative to distant pulsars, like a cosmic map. The records themselves contain sounds and images from our world, the sound of wind and rain, the cry of a baby, the music of Bach and the blues, greetings spoken in 55 different human languages. They contain pictures of our cities, our farms, our art, our people. They are a message in a bottle, cast into the cosmic sea, a beautiful, hopeful gesture from a small blue world, a testament to our desire to be known. Listening for signals is one way to search, but in the last few decades, a new and powerful method has emerged. We have started to look not just for signals, but for the worlds themselves. We have become planet hunters. For most of human history, we only knew of the planets in our own solar system. We did not know for sure if any other stars had planets of their own, but now we know. Thanks to amazing space telescopes like the Kepler mission and now the James Webb Space Telescope, we have found planets orbiting other stars. We call them exoplanets, and we have not found just a few. We have found thousands upon thousands. The sky is full of them. We find them in several clever ways. One is called the transit method. Imagine watching a distant, bright streetlight. If a tiny moth flies in front of it, the light will dim just a tiny bit for a moment. Our telescopes watch distant stars, waiting for a similar dip in brightness, a tiny regular dimming that tells us a planet is orbiting that star, passing in front of it from our point of view. Another way is the radial velocity method, or the wobble method. A planet doesn't just orbit a star. The star and the planet orbit a common center of gravity. A big planet can make its star wobble just a tiny bit. We can detect this wobble in the star's light, telling us an unseen planet must be there, pulling on it. Using these methods, we have found a zoo of strange and wonderful worlds. We have found hot Jupiters, giant gas planets, orbiting closer to their stars than Mercury does to our sun. We have found super-Earths, rocky worlds much larger and more massive than our own. We have found planets that orbit two suns at once, like the fictional world of Tatooine from Star Wars. We have even found rogue planets, adrift in the darkness, not orbiting any star at all. Each discovery is a new possibility, a new place where the story of life might have begun. Now, we are learning to do something even more incredible. We are learning to study the air of these distant worlds, their atmospheres. The James Webb Space Telescope is a masterpiece of engineering designed for this very purpose. When an exoplanet passes in front of its star, a tiny, tiny amount of the star's light filters through the planet's atmosphere before it reaches our telescope. We can catch that light, and we can spread it out into a rainbow, a spectrum. Different gases in an atmosphere absorb light at very specific wavelengths. They leave behind a chemical fingerprint, a barcode of dark lines in the star's rainbow. By reading this barcode, we can see what chemicals, what gases, make up the air on a world light years away. We are looking for something called a biosignature, a chemical fingerprint that hints at the presence of life. Think about our own planet, Earth. Our atmosphere is filled with oxygen, but oxygen is a very reactive gas. It doesn't like to stay free. On its own, it would quickly combine with other elements and disappear from the air. The reason our air is full of oxygen is because of life. The constant, gentle breathing of plants and algae, photosynthesis, pumps our atmosphere full of it, day after day. If we were to look at a distant, rocky planet and find its atmosphere was rich in oxygen, and perhaps other gases like methane, which also are often tied to life, it would be a breathtaking discovery. It would not be absolute proof of aliens. There could be some strange, non-living chemical process that we don't yet understand, but it would be a powerful clue, a tantalizing hint. We could also look for signs of industrial pollution, a techno-signature, which would be even more stunning. The search for these whispers, these fingerprints in the light, is happening right now as you sleep. We are no longer just listening for voices. We are learning to see the breadth of distant worlds. While we look to distant stars in other solar systems, we also look for signs of life right here in our own cosmic neighborhood. Perhaps we have neighbors closer than we think. For centuries, our hopes were pinned on our red neighbor, Mars. In stories and in dreams, it was a world of ancient canals and mysterious civilizations. Today, our rovers travel across its surface, and we know that Mars is a cold, dry, rusty desert. Its air is thin. Its surface is blasted by radiation from the sun. But it was not always this way. Billions of years ago, Mars was a warmer and wetter world. Our rovers have found the smooth, rounded pebbles of ancient riverbeds. They have discovered the dried, cracked mud of what were once vast lakes. We have seen the faint outlines of enormous river deltas. Mars had blue skies, white clouds, and liquid water. It had all the ingredients for life as we know it. So the question is, did life begin there? Did simple microbial life arise in those ancient Martian oceans? And if it did, could it still be there? Could tiny, simple life forms be clinging to existence deep underground, perhaps in pockets of salty water, where the freezing point is lower, or in caves sheltered from the harshness of the surface? Our search on Mars today is not for cities, but for the fossilized ghosts of ancient microbes, or perhaps even the faint chemical traces of life that still endures. But Mars is not the only place of interest. Some of the most exciting possibilities are not on planets, but on the moons of giant worlds. Circling the giant planet Jupiter is a moon called Europa, and circling the ringed planet Saturn is a moon called Enceladus. Both of these worlds are covered in a thick global shell of water ice. They are cosmic snowballs, shining brightly in the sun. But beneath that ice, something amazing is happening. The immense gravity of their host planets, Jupiter and Saturn, constantly squeezes and stretches these moons, like squeezing a rubber ball in your hand. This constant kneading generates heat deep inside them. Enough heat to maintain vast global oceans of liquid water, oceans that may have existed for billions of years. We have seen proof of these oceans on Enceladus. We have seen enormous geysers of water vapor and ice crystals erupting from cracks in the moon's south pole, spraying out into space. Our spacecraft have flown through these plumes and tasted them. We found water, salts, and organic molecules. Everything you need to build a habitable environment. On the floor of Earth's own deep oceans, far from the light of the sun, we have found places called hydrothermal vents. They are like chimneys on the seafloor, spewing hot chemical-rich water from the planet's interior. And clustered around these vents, an entire ecosystem of life thrives. Strange tube worms, ghostly fish, and countless microbes. They live not on sunlight, but on chemical energy from the Earth itself. Could similar vents exist on the dark seafloor of Europa or Enceladus? Could life be thriving there? Right now, in the eternal silent darkness beneath miles of ice. A whole world of life, completely unaware of the sun, the stars, or us. These hidden oceans are among the most thrilling places we plan to explore. Our explorations on our own planet have taught us something profound. They have taught us that life is far more stubborn, far more creative, and far more tenacious than we ever dreamed. We once thought life needed gentle, garden-like conditions to survive, but we were wrong. We have found life in the most extreme environments you can imagine. We have found tiny microbes that thrive in the boiling water of hot springs in Yellowstone. We have found them living inside solid rock, miles beneath the Earth's surface, living on a diet of minerals and water. We have found them in water so acidic it would dissolve metal. We have found them in the crushing absolute pressure of the deepest ocean trenches, a pressure equivalent to having 50 jumbo jets stacked on top of you. We have even found that some of these tiny life forms, like the incredible tardigrade or water bear, can survive the vacuum and radiation of open space. They can dry out completely, becoming a lifeless speck, and then years later, with a single drop of water, return to life. We call these rugged little beings extremophiles. It means lovers of the extreme. And what these extremophiles teach us is that we need to broaden our imagination. They show us that the definition of a habitable world might be much, much wider than we thought. We should not just look for perfect copies of Earth. Life might not need a gentle sun and blue skies. Perhaps life could exist on a super-Earth with crushing gravity. Perhaps it could thrive in the thick, soupy, orange atmosphere of a world like Saturn's moon, Titan, where it rains liquid methane into vast, cold lakes. Perhaps simple life could even float in the clouds of a planet like Venus, where the surface is hot enough to melt lead, but high in the atmosphere, the temperature is quite pleasant. The universe of possibilities is far wider, far stranger, and far more wonderful than we once believed. Life may not look like us. It may not think like us. It may be thriving in places we would consider impossible. The lesson from Earth is to expect the unexpected and to look for life in every conceivable niche the cosmos provides. And so we return to the great, profound silence. We return to the Fermi Paradox. If the universe is full of potential homes for life, and if life is so tenacious, then why? Why is the cosmos so quiet? There are many possible answers. They are just ideas, just stories we tell to try and make sense of the silence. Some are hopeful, some are strange, and some are deeply sobering. One of the most thought-provoking ideas is called the Great Filter. The Great Filter is a hypothesis. It suggests that on the long, difficult road from a simple, non-living molecule all the way to an advanced civilization that can travel between the stars, there is a wall, a barrier, a filter. It is some step in that evolutionary journey that is incredibly difficult or incredibly unlikely to pass. It is a challenge that almost no form of life can overcome. And this leads to a truly profound and chilling question, a question we must ask about ourselves. Where is this great filter in our own story? Is it behind us? Or is it still ahead of us? Let's think about the first possibility. What if the great filter is in our past? This would mean that one of the steps we have already taken was the incredibly rare and difficult one, perhaps the origin of life itself, the first spark that turned non-living chemistry into a living, replicating cell, is an event of astronomical rarity. Perhaps it has only happened once, here on Earth, in our entire galaxy. Or perhaps the filter was the leap from a simple single cell to a complex multicellular creature like a plant or an animal. That step took billions of years on Earth. It requires incredible feats of cellular cooperation. Perhaps it almost never happens elsewhere. If this is true, if the filter is behind us, then we have won a cosmic lottery of unimaginable odds. We may be the first intelligent species in our galaxy, or perhaps the only one. The silence is not a mystery in this case. The silence is simply because the universe is empty. We are alone. A precious, lonely miracle. But then, there is the other possibility, the more chilling thought. What if the great filter is ahead of us? This would mean that the early steps are easy. Life arises often. Intelligence evolves often. Technology develops often. The galaxy could be full of civilizations that have reached the same level we are at right now. But then, they encounter the filter, and they do not pass it. What could this future filter be? Perhaps it is a technological one, the invention of something so powerful, it inevitably leads to self-destruction. Artificial intelligence that grows beyond the control of its creators, or weapons of unimaginable power that are too easy to create. Or perhaps the filter is a social one. The tendency for a civilization to exhaust its planet's resources, to change its own climate so drastically that it collapses, the inability to cooperate on a global scale to solve existential threats. In this scenario, the silence we hear is a graveyard. It is the sound of countless civilizations that rose and dreamed, that reached for the stars, but that fell into ruin before their voices could ever cross the interstellar void. It is a warning, written in the silence of the stars. But perhaps the answer to the silence is not so lonely and not so apocalyptic. There are other possibilities, other stories the silence might be telling. One is a strange and fascinating idea called the zoo hypothesis. In this scenario, advanced civilizations are out there. They are all around us, and they know we are here. But they have made a deliberate choice not to contact us. They are observing us, the way we might observe animals in a vast, protected nature preserve. They may have a strict rule, a prime directive of non-interference. They are letting our young, chaotic civilization grow and develop on its own, without the contamination or disruption that contact with a vastly superior culture would bring. We are an exhibit, a protected piece of the galactic wilderness. The silence, in this case, is not emptiness. It is the sound of a carefully kept garden. Another, more paranoid idea is called the dark forest hypothesis. Imagine you are a lone hunter walking through a dark forest at night. The forest is full of other hunters. Some may be friendly, some may be hostile. You cannot know. The one thing you do know is that the first hunter to make a sound, to light a fire, reveals their position to everyone else. The safest possible thing to do is to stay completely silent, to melt into the darkness. In this scenario, the universe is not empty. It is full of intelligent life. But everyone is hiding. Everyone is listening, but no one is broadcasting, because to announce your existence is to invite potential attack from someone older and more powerful. The silence of space in this story is the silence of fear. Then there are ideas that take us even further from our everyday experience. Consider the estivation hypothesis, Estivation is like hibernation, but for surviving heat and dryness rather than cold. This idea suggests that the universe is currently too young, too hot, and too chaotic for truly advanced, information-based life. The stars are burning fiercely, supernovae are exploding. It's a messy, high-energy environment. A truly advanced civilization, perhaps one that has uploaded its consciousness into computers, would find this wasteful. Their goal would be information processing. And processing is most efficient in the cold. So, this hypothesis suggests the advanced civilizations are simply sleeping. They are dormant, waiting for trillions of years in the future, when the stars have burned out and the universe has cooled down to nearly absolute zero. In that far, far future, the universe will be a cold, dark, quiet place, perfect for efficient computation. They are waiting for the right time to awaken and live their true, long lives. The silence we hear is the sound of a galaxy taking a nap. Or, what about the transcension hypothesis? This idea proposes that the goal of a mature civilization isn't to expand outwards into space, building a galactic empire. Instead, their goal is to expand inwards. They engineer and explore inner space. They might create simulated universes, perfect digital worlds to live inside. They might discover the deepest laws of physics and learn to live as pure energy. They might shrink themselves down to microscopic size to live in a world of unimaginable complexity. From our point of view, they would simply disappear. They would lose all interest in our clumsy, physical world of stars and planets. The silence in this case isn't because they are dead or hiding. It's because they have graduated to a new level of existence that we cannot even begin to imagine. They have moved on. Or maybe, and this is a truly humbling thought, maybe their communication is simply beyond us. Imagine trying to explain the internet, with all its videos and music and information, to an ant. The ant lives in a world of chemical trails and pheromones. It wouldn't even have the capacity to recognize your communication as communication. It would just be meaningless background noise. Perhaps we are the ants. Perhaps we are floating in a vast ocean of messages and signals right now. Signals that are not radio waves. Signals that are woven into the fabric of space-time, or use dimensions we cannot perceive. The silence might not be an absence of communication. It might just be our own inability to understand the language of the cosmos. And so, our calm journey through the cosmic quiet comes to a gentle close for tonight. We have not found a simple answer to the great question, where are they? We have only found more questions, deeper mysteries, and a more profound sense of wonder. We have found stories, possibilities, that stretch our minds and carry us far from our everyday lives. But perhaps the point of the journey is not to find the answer. Perhaps the real beauty is in living with the question itself, letting it expand our minds, our sense of what is possible, and our appreciation for our own fragile, beautiful living world. Whether we are alone in the cosmos, or whether we are part of a vast, unseen community, we are the part of the universe that has become aware. We are the part of the universe that looks up at the stars and wonders. And there is a quiet, gentle magic in that. It is a privilege to be able to ask the question. So now, as you drift off into a deep and peaceful sleep, let these cosmic mysteries cradle you. Let the silence of space be a blanket of comfort and peace. The stars will continue their slow, silent dance. The planets will continue their graceful orbits. and the great unfolding story of the universe will continue through the night. And you are a precious part of that story. Rest now, sleep well.